Hello, Prashant, can you hear me?
Yes, sir.
Okay, so my screen is not visible. Can you see my slides?
Yes, sir.
Okay, so there was a technical issue, so that so now we can continue the discussion. So the first problem is, I request you to please mute yourself. So the problem says a certain system is described by the operator a cap, which is given by minus d square by dx square plus x square, and the wave function psi equals to c x into e to the power minus x square by 2 is the eigenfunction of the operator a, and c is any arbitrary constant. So find out the eigenvalues. Option A is 2, option B is 3, option C is 4, and option D is 5. So now you see the question says the operator is the operator a cap is given by minus d square by dx square plus x square, and the wave function psi is given by c x e to the power minus x square by 2. So this is the wave function. Now here in this question, we need to find out the eigenvalue of this particular wave function in the operator A. So basically in quantum mechanics, what happens, every physical quantity is associated with an operator, and like in uh, so if you want to have any information related to the system, you first need to find out the wave function of that system. So after getting the wave function, if you operate the if you operate the operator on that particular wave function, then you get information about different physical quantities. So now here a system is described by operator a cap. So in order to find the eigenvalue, we know the eigenvalue equation is basically written as a cap psi equals to a psi. So when we operate the operator a cap on the wave function psi, if the wave function is again being reproduced, then the value will be a, and this a is called as eigenvalue. So if in both the sides the wave function remains same, the wave function does not change, then the resulting value after operating the operator will be called as the eigenvalue. So now we will solve it. So now like here we will first do a cap psi. So a cap psi is, what is a cap? A cap is minus d square by dx square plus x square into psi, which is equals to minus d square by dx square plus x square into f function is cx e to the power minus x square by 2. Then solving it, it will be equals to minus d square by dx square cx e to the power minus x square by 2 plus simply x square into cx e to the power minus x square by 2. Then taking the derivative twice, then first it will be c will be coming out because it is a constant. So then taking the first derivative, you will get e to the power minus x square by 2 minus 2x by 2 into x into e to the power minus x square by 2 plus x cube cx cube e to the power minus x square by 2. Then again taking the derivative, it will be minus c e to the power minus x square by 2 will be minus x into e to the power minus x square by 2 minus 2x into e to the power minus x square by 2 plus x cube into e to the power minus x square by 2 plus c x cube e to the power minus x square by 2. Then you see this is c x cube to the power minus x square. It is minus c x cube. So this term will get cancelled out. Then this is x e to the power minus x square. It is 2x e to the power minus x square. So it will be minus c into minus 3x e to the power minus x square by 2. It will be 3 into c x e to the power minus x square by 2. So if you see here, this cx e to the power minus x square by 2 is nothing but the wave function. So we can write a cap psi equals to 3 into psi. So the eigenvalue for this particular wave function is 3. So the correct option will be option B, which is 3. So is this clear to you? So what we did here, we are provided with an operator which was the form of the operator was minus d square by dx square plus x square, and the wave function was cx into e to the power minus x square by 2. So when we operate the operator on that wave function, it again produces the same wave function with the eigenvalue of 3. Because if you see, if you take the derivative twice and then calculate it mathematically, then you will again reproduce the wave function, that is cx e to the power minus x square by 2 along with the value 3, and this value 3 is known as the eigenvalue. I hope this is clear to you. Then we will proceed to the next problem. Is this clear or you have any doubt? Hello, Prashant, can you hear me? Okay, so let's go to the next question. The question says the wave function psi equals to 3 e to the power minus 5x is the eigenfunction of the operator d square by dx square. Then what will be the eigenvalue corresponding to this? The options are option A 15, option B 25, option C 45, and option D 55. So like uh, if you compare it with the previous question, it is pretty much similar. In that case, there was also the eigen value was asked. Here, the form of the operator is different and the wave function different. but the question is same. We need to find out the corresponding eigenvalue. So you need to simply operate the operator on that wave function. Then if you take the derivative twice, then you will be getting again the same wave function along with some value, and that value will be called as the eigenvalue. So I'll give you a few minutes to try this question, and then we will discuss. Yes, did you solve it? So can you tell me what will be the corresponding eigenvalue of this wave function and the operator? Okay, so again, we'll solve. It will be pretty much similar to the previous question. So like here, this operator has the form of d square by dx square, and the wave function psi is d e to the power minus 5x. So when we operate the operator on the wave function, it will be d square by dx square into 3 e to the power minus 5x. So it will be d by dx of 3 to the power minus 5x into 5. Then it will be d by dx of 15 into e to the power minus 5x. Then it will be again 15 into 5 into e to the power minus 5x. It will be 75 into e to the power minus 5x. If you compare it, it will be a cap psi will be 25 into 3 e to the power minus 5x. So this 3 e to the power minus 5x is nothing but the psi wave function which was given in the question. So we know a cap psi is equals to a psi, and a is the eigenvalue. So here a is 25. So 25 will be the correct answer. So if you see here, this 25 is this a. So the correct option will be option B. So is this clear to you? Like to the like the previous question, we again operated the operator d square by dx square on the wave function side. So if you take the derivative twice, then since it is an exponential, so e to the power minus 5x, the derivative of e to the power minus 5x will be minus 5 into e to the power minus 5x. So here it will be minus 5. Then again in the next, it will be minus of minus, so it will be positive. It will be plus 75 will be plus 75 into e to the power minus 5x. Then if you compare it with the original wave function, the original wave function was 3 to the power minus 5x. So the eigenvalue will be 25 in this case. But if the question was like, suppose now here the question will be, suppose d by dx is the operator, what will be the eigenvalue then? So if you operator the operator d by dx, this wave function c e to the power minus 5x, suppose. So it is 3, sorry. So a cap psi will be d by dx of 3 e to the power minus 5x, which will give you minus 3 into 5 e to the power minus 5x. So minus 5 into 3 e to the power minus 5x. This is psi, it will be minus 5 psi. So here minus 5 will be the eigenvalue. So here the correct option will be option B. Now let's go to the next question. The question says, find out the values of x cap to the power n and px cap commutator where n is a positive number. The options are option A, h by 2 pi I minus h by 2 pi I n x to the power n minus 1. Option B is h by 2 pi I x to the power n. Option C is n x to the power n minus 1. And option D is hn divided by 2 pi I. So these are the 4 options. And this is basically the question says what will be the question says what will be the commutator of x to the power n cap and p cap. But we know x cap, px cap, the commutator value is ih cross or ih by 2 pi. So if the commutator relation of x cap, px cap is ih cross, then what will be the commutator commutator relation of x to the power n and px cap? So I'll give you a few minutes to try this. I request you to try on your own and then we will discuss what will be the correct option out of this four. So yes, can anyone tell me what will be the correct option? Yes, anyone? Madhusmita, can you hear me? Hello. Can anyone tell me what will be the correct option? Okay, so since you are not responding, so I will solve it. Now, by means of commutator, we mean suppose the commutator of x cap and p cap is given. It is basically x cap px cap minus px cap x cap. So we know this is the value of the commutator. So because if you operate the wave function psi here, you will get I h cross psi. So it will be psi, and if you solve, you will at last get I h cross psi. But here the question is different. The question says what will the value of x to the power n and px here. So how can we solve it? It will be x to the power n px cap minus px x to the power n into psi. So it will be x to the power n. We know px cap as the form minus I h cross d by dx into psi minus I h cross d by dx into x to the power n psi. So it will be minus I h cross x to the power n d psi by dx. Because here if you see, if you operate it, x to the power n is outside, so it will be simply minus I h cross into x to the power n d psi by dx. But here it will be different. It will be minus is minus I h cross d by dx of x to the power n psi. So first, if you take x to the power n outside, it will be again minus I h cross d psi by dx. Then minus I h cross d by dx of x to the power n and psi. Then it will be minus I h cross x to the power n d psi by dx plus I h cross x to the power n d psi by dx plus I h cross x to the power n minus 1 into n into psi. Because the d by dx, this is outside. So the derivative of x to the power n is n into x to the power n minus 1. So this two get cancels out. The remaining is I h cross x to the power n minus 1 n into x to the power n minus 1 into psi. So here it was psi, then this is psi. So if you see x to the, so we found x to the power n px cap minus px cap x to the power n cap. It will be I h cross n x to the power n minus 1. So the commutator of x to the power n and px cap will be I h cross n x to the power n minus 1. So this will be the correct option. If you see the options, because but in the options there is no h cross, so we know h cross is nothing but h by 2 pi. So if you multiply I in the numerator and denominator, it will be minus h by 2 pi I n x to the power n minus 1. So the correct option will be option A, minus h by 2 pi I n into x to the power n minus 1. So the correct option will be option A. Is this clear to you? So since you are not responding, I also am unable to verify that whether I am being audible to you clearly or not. You are just here. You are not responding to my questions also. So I can't also anticipate that whether you are listening to me or my voice is clear to you or not. So I hope you'll be interacting in future discussions. So let me explain it once again. So basically the question says what will be the commutator relation of x to the power n and px. We know the commutator of x cap and px cap is IH cross. So similarly, if we put the formula x cap px cap, commutator stands for x cap px cap and px cap x cap. X cap px cap minus px cap x cap. So this is IH cross pi. So similarly, if you put the values because we know the form of the operator x cap is x only. So it is x to the power n px cap minus px x cap psi. If you see here, this x to the power n is outside, so you will simply put the value of px cap here. But here, this is a product. So if you put the derivative formula, then in first case x to the power n will be remaining, and then the derivative of psi will be taken, and in second part it will be the derivative of x to the power n. So if you take the derivative of x to the power n, it will give you n into x to the power n minus 1. So these two terms, the first term and the second term will get cancelled. Then the remaining term will be I h cross n x to the power n minus 1. So here we have taken psi here. So if the psi here is taken, then the psi is being reproduced. So denoting psi on both the sides, you will get the commutator relation of x to the power n and px cap is IH cross n x to the power n minus 1. But the options, if you see the options are in terms of h. So if you put in place of h cross, you put h cross by 2 pi, then you will get the option A is correct. So let's go to the next question. The question says, so is my screen is visible all to all of you? Nandini, can you hear me? Hello.
Yes, sir.
So my screen is visible to you clearly?
Yes, sir.
Okay. So the question is, the particle in a one-dimensional box of length L are associated with the normalized wave function, which is given by psi n equals to n sine n by x by L. Find out the value of normalization factor n of the given wave function. The options are option A, L by 2, option B, 2 by L, option C, pi by 2, the option D, root n pi. So the question says, it is the scenario of a particle in one dimension box of length L. So this is the form of the potential. It is a one dimension box of length L, means the potential is from 0 to L. So the form of the potential is Vx is equal to 0 for x 0 to L and Vx equal to infinity other than it. So here it is infinity and here it is infinity. So and in between from 0 to L, the potential is 0. So the particle is in that one-dimensional box and the wave function of the particle is given by psi n equals to n sine n pi x by n. So we all know it clearly. The wave function of the particle in one-dimensional box has the form of n sine n pi x by n, where n stands for different levels. N is equal to 1 for the first level, n equal to 2 like this. But here, if you see, it is given, it is associated with the normalized wave function. The wave function is normalized. This is the form of normalized wave function. So if this is the form of normalized wave function, then what should be the value of n, which is called a normalization factor. So n is the normalization factor. So what will be the value of n? So these are the options. So can anyone tell me what do we mean by normalized wave function? Yes, anyone? Prashant, can you hear me?
Yes,
So
sir.
so you know about the wave function and particularly in one-dimensional box. Have you learned about it in past days or any? So in which course you are in? You are in BSc or you are in MSc?
Yes, sir.
So you know about these wave functions, particularly in one-dimensional box and all. Yes. So you know about these things, these concepts, what is wave function, how the wave function form is derived, what will be the behavior of particle in a one-dimensional box. Do you know about it or not? Hello? And the remaining two, Madhusmita, are you familiar with these concepts like what is the wave function, what is one-dimensional potential box? Are you familiar with it? Again, you are not responding. So if you won't respond, then what is the meaning of this interaction session? So if you don't know these concepts, I will try to explain it in a more detailed way. But if I continue solving like this and you won't ask any question, then what will be the exact intention of this interaction session is to you should interact with me if you have any doubt related to the course. So from my side, I am solving the problems. But if you have any other problems, other queries, I can also try to solve them or try to discuss in this interaction session. So again, you are not responding. So let's continue our question solving. So basically, these are the four options. And by normalization, what we mean, so according to quantum mechanics, every system is characterized by a wave function, and the wave function has a certain form. So here, for this type of potential, which is one-dimensional box potential, the wave function has the form psi n equals to n sine n pi x by n, where n equals to 1, 2, 3, like this. So what do we mean by normalization? Normalization means we know wave function basically signifies about the probability of the particle. So and psi mod square gives about the probability of finding the particle. So since here the potential is 0 from 0 to L and it is infinite everywhere, so the particle should be contained in this box a potential 0 to L. According to this, so phi square, if you calculate from 0 to L, it should be 1. So this is called as the concept of normalization. That is in general normalization is given as minus infinity to plus infinity psi star psi dx. This psi star psi is nothing but psi mod square. But here if you see the particle is contained within the region 0 to L, that is x from 0 to L. So the total probability, which is here minus infinite to plus infinite, which is equal to 1. Now since all the other regions of x, the potential is infinite, so the particles must be contained within 0 to L. So in this case, the normalization condition will be integration 0 to L psi star psi dx equals to 1. This is the normalization equation. So if you integrate it, we know psi is what? Psi is, so here it will be psi n star psi n. So psi n is n sine square n pi x by L. So not square, it will be n sine n pi x by L. So if you put here, it will be 0 to L. Since this is real, psi n star will be equals to psi n, is not it? So it will be n sine n pi x by L into n sine n pi x by L dx equals to 1. So it will be n square 0 to L sine square n pi x by L dx equals to 1. So n square, we know sine square n pi x by L, it will be 1 minus cos n pi x by L. So to half 0 to L equals to 1, because 1 minus cos 2x is 2 sine square x. So if you integrate it, what will you get? N square into n square by 2 can be taken out. It will be L minus 0. So it will be L minus 0 minus of L by 2n pi 0 minus 0. So it will be n square by 2 equal n square by 2 into L equals to 1. So n will be 2 by L root of. So this n will be 2 by L root of. So the correct option is option B. Is this clear to you? Yes, anyone? Okay, so question was the part there is a system given. The system is basically a one-dimensional infinite potential box, and the wave function has the form psi n equals to n sine n pi x by l, where n is the normalization factor n. What should be the value of n? So according to the normalization condition, the integration of wave function from minus infinity to plus infinity should be 1, or the total probability of finding the particle in this universe should be 1. So here the potential region is only 0 to L. So the integration from 0 to L of psi n star psi n dx equals to 1. So if you put the values and integrate it, it's simply a mathematical calculation. So if you integrate it, the value of n you will get 2 by L root over. So this is the correct answer. Now, question number 5. The question says find the expectation value of x for a particle in a one-dimensional box of length L and the normalized wave function of psi n 2 by L sine n pi x by L. So in the like the previous question, we just got the answer. The normalization constant, this is n normalized constant, which is 2 by L root over. So now the normalization or the normalized wave function is given. We need to find out the average value or the expectation value of x. The options are option A L by 2, option B 2 by L, option C 2 by n pi, and option D n pi by 2. So I will give you a few minutes. I hope you will try to solve. Then we will discuss. Yes. Anybody tried to solve it? Okay. So basically, what do we mean by expectation value? Basically, it is the average value. The formula for expectation value or average value is integration 0 to L psi star x psi dx divided by 0 to L psi star psi dx. So in the previous question, we just calculated this value is 1 if the wave function is normalized simply the expectation value of x will be integration 0 to L psi star x psi dx. So if you calculate x, or we can write it as x bar, which will be 0 to L x sine square n pi x by L, n pi x by L. Here it will be 2 by L, because the root over of 2 by L, root over 2 by L, it will be 2 by L sine square n pi x by L dx. Now if you integrate it, what you will get? Now here it is x sine square n pi x by L. So the integration means it will be 2 by L by n pi. Sorry, there will be a change of parameter here before we take the integration. So let u equals to n pi x by L, n pi x by L. Then du will be n pi by L into dx. So dx will be L by n pi into du. So what will be the value? X bar will be 2 by L by n pi square 0 to 2 pi u sine square u dx. Because here when x equal to 0, u equals to 0. When x equal to L, u will be 2 pi. Because when x equal to 0, u equals to 0. When x equals to L, u is 2 pi. So it will be 2L by n pi square. Then the integration of u sine square u 0 to 2 pi n pi, because x n pi x by L is u. So if you put n pi x by L 3. So when u is equal to 2 pi, so 2 pi. So when x equals to L, x equal to L equal to n pi L by L. L get cancelled out, u equals to n pi. When x equal to 0, u equal to 0, and when x equal to L, u is equal to n pi. So the integration will be u square by 4 minus u sine 2u by 4 minus cos 2u by 8, 0 to n pi. So basically here u sine square u, you will put sine square is equal to 1 minus cos 2u by 2. Then if you solve it, you will get these values. So if you put the values, it will be 2L by n pi. Then we put this n pi, then n pi square by 4 minus n pi into sine 2n pi by 4 minus cos 2n pi by 8. then minus 0 minus 0 minus 1 by 8. So if you solve it, it will be 2L by n pi square into n pi square by 4, because the sine 2n pi is 0 and this cos 2n pi by 8 is minus 1 by 8, and minus 1 by 8 plus 1 by 8 gets cancelled out, so it will be only 2L by n pi into n pi by. So here this minus 1 by 8, this will be minus of minus 1 by 8 plus 1 by 8, and this will be cos 2n pi is 1, so it will be again 1 by 8. So these two will be getting cancelled out. So the remaining will be how much? It is 2. 2 gets cancelled out, it is 2. Then n pi square gets cancelled, it will be L by 2. So this is the average value of x. So you see, if you find the expectation value or the average value of x for a particle in one-dimensional box of length L, then the expectation value of x is L by 2. So we have taken the normalized wave function, and since the wave function is normalized, this denominator becomes 1, and when this denominator becomes 1, we simply need to take the integration. If you take the integration and there is change of variable in the process, and if you put the if you when you are changing the integration variable, then similarly the limits of the integration will be changed. So when you change the limit of the integration and you calculate, you get the value is L by 2. So the correct answer will be option B, option A, sorry, option A, which is L by 2. Then question number 6. Question says a particle is in a three-dimensional box whose sides are Lx, Ly, Lz by 2 equals to L. Then find out the energy value for Nx equal to 1, Ny equal to 1, Nz equals to 1. Nx, Ny, Nz all are equal to 1. The options are option A, 12 h square by 32 ml square, 21 h square by 32 ml square, 24 h square by 32 ml square, or 9 h square by 32 ml square. So, can anybody tell me how we will proceed with this problem? Yes, anyone? How we will solve this problem? In previous problems, we were talking about particle in one-dimensional box, but here we are talking about particle in three-dimensional box. So how we will proceed with this problem? Yes, anyone? How we will proceed with this problem? So basically, in particle in one-dimensional box, the energy agent value is given by En is equals to n square h square by 8 ml square. This is in one-dimensional potential box. But in case of three-dimensional potential box, this is given by this n square gets converted to nh square plus ny square plus nz square divided by 8 ml square. So this is only possible when this L is same, like if you make it more general, it will be En equals to h square by 8m will be nx square by s square plus ny square by b square plus nz square by c square. So here Lx is A, Ly is B, and Lz is C. But here if you see, Lx, Ly, Lz are not equal. So Lx is L, Ly is L, but Lz is 2L. So we will put here Nx equal to 1, Ny equal to 1, Nz equal to 1, and A we will put L square, A square. In place of A square, we will put L square. In place of B square, we will put L square. In case of C square, we will put this C is 2L, so we will put 2L square, which is 4L square. So what will be the energy? E will be h square by 8m. L square means 1 by L square plus 1 by L square plus 1 by 4L square. Here Nx, Ny, Nz are 1, but these values are different, so we will put like this. Then it will be h square by 8m. If you take the summation, it will be 4L square. It will be 4 plus 4 plus 1. So 4 plus 4 plus 1 is 9. It will be 9 h square divided by 8 into 4, 32 ml square. So this is the value of energy for the given question. So let me explain it once again. So the general form of energy agent value is En is n square h square divided by 8 ml square, which is for one dimensional potential box, and the length of their potential box is L. But if you convert it into 3 dimensions, this N, that is the states, are again divided into Nx, Ny, and Nz. It will be Nx square plus Ny square plus Nz square. And here in the denominator, we can also take different values of L. Here the single L square means all the dimensions along these 3 dimensions x, y, and z are similar. So in both the cases, it will be L square, L square, L square. So, but in general, if the dimensions are not equal in 3 directions, 3 orthogonal directions, so we can write it as n square by a square plus ny square by b square plus nz square by c square. So here in this question, there is a trick. Lx and Ly, they are equal to L, but Lz is not equal to L. So we will use the third formula, which is written here. We will use this formula. So after using this formula, what we will get? Nx is 1, Ny is 1. We have put here Nx is 1, Ny is 1, Nz is 1, Lx is L, Ly is L, but Lz is 2L. So L square, but in case of Lz, we have put 2L, which is 4L square. So if you calculate, the energy will come out to be 9h square divided by 32 ml square. So the correct option is option D, 9h square divided by 32 ml square. Is this clear to all of you? Yes, anyone? Are you getting what?
Yes, sir.
Okay, so Madhusmita, you are from MSc or you are doing BSc?
MSc, sir.
Okay, so I wanted to tell that I am also from Odisha. I can anticipate that you are from Odisha.
Yes, sir. Yes, sir.
So if you have any doubt related to the questions I am solving, so feel free to ask me. I will try my best to explain you. So this was a trick question where the dimensions along these three axes were different. That's why we use the latter formula. But simply if there was no restrictions regarding the dimensions, we can simply use the second formula, which is nx square plus ny square plus nz square. So can you calculate and tell me? Suppose the question says nx is 1, ny is 2, and nz is 3, and both lx equals to ly equals to lz equals to a. Then what will be the value of energy? Can anyone tell me what will be the energy value? If Lx, Ly, Lz all are same, Nx is 1, Ny is 2, and Nz is 3. Yes, anyone? Prashant, can you hear me? So if you see, we can use the second formula here. Here, the L is same for x direction, y direction, and z direction. So you will use this formula. The formula will be nx square plus ny square plus nz square. So the energy will be a square divided by 8 ml square. Nx square is 1 square. Ny square is 2 square.
2
Plus
square
nz
plus
square is 3 square.
3 square.
Yes.
Okay.
So it will be h square by 8 ml square into how much? 9 plus 4 plus 1 will be 14.
9, 4, 14.
So it will be 14 h square divided by 8 ml square. Or simply you can say it is 7 h square divided by 4 ml square. Is this
Okay.
clear to everyone?
Okay, sir. Okay, sir.
Yes, is this clear to everyone?
Okay, sir.
Okay, no, there are other students also, na? They are not responding till now. Okay, so let's solve the next question. I request you to mute yourselves. Then the question number 7, the question says, a particle in a one-dimensional potential box of side L as associated with the normalized wave function psi n, which is given by 2 by L sine n pi x by L. What will be the probability of the particle? What will be the probability of finding the particle in the region 0 to L by 4? So here, this is a one-dimensional box of length L. The particle is present here. The wave function of the particle is given by 2 by L sine n pi x by L. Then for state 1, that is n equal to 1, what will be the probability of the finding? What will be the probability of finding the particle between x equals to 0 to L by 4? The options are option A 0.0705, option B 0.0908, option C 0.1208, or option D 0.2105. So I will give you a few minutes to try this question. Then after some time we will solve it. Yes, can anyone tell me what will be the probability of finding the particle in n equal to 1 state within the region 0 to L by 4? So if you remember, we were solving the normalization problem. There the probability of finding the particle from 0 to L was 1. So here we will find the probability of the particle from 0 to L by 4. So simply we can change the limit of the integration. So what it will give? The probability of the particle from 0 to L by 4 is integration from 0 to L by 4 pi star psi dx. So it will be 0 to L by 4. The wave function is given. It is 2 by L sine square n pi x by L dx. So it is 2 by L integration 0 to L by 4 1 minus cos 2 pi x by L divided by 2 into dx. It will be 1 by L 0 to L by 4 1 minus cos 2 pi x dx. This is 1 by L x 0 to L by 4 minus L by 2n pi sine 2n pi x by L 0 to L by 4. It is 1 by L by 4 minus 0 minus L by 2n pi sine n pi by 2 sine n pi by 2. So if you put here L by 4, in x will be L by 4, so L get cancelled out. 2 cancelled with 4, it will give sine n pi by 2. It will be 1 by 4 minus 1 by 2n pi sine n pi by 2. So if you put n equal to 1, it will be 1 by 4 minus 1 by 2 pi into sine pi by 2. Sine pi by 2 is 1. It will be 1 by 4 minus 1 by 2 pi. It will be 0.25 minus 1 by 2 pi will be how much? 1 divided by 6.2. 0.25 minus 1 by 2 pi. So 5 3.142. So it will be 1 divided by 2 pi equals to 0.159. 0.159. It will be how much? It will be it will be 0.0908 approximately. So the correct option will be 0.0908. So is this clear to you? The question says the particle is in one-dimensional potential box. The normalized wave function has the form 2 by L sine n pi x by L. What will be the probability of finding the particle between 0 to x between 0 to L by 4. We just solved in case of a normalization problem the total probability of finding particle in the whole space, that is 0 to L, is 1. So similarly here we need to integrate the normalization equation, but the limits will be changed from 0 to L by 4. So if we do that, we will obtain the probability of the finding particle will be 0.0908, because if you see psi mod square is nothing but the probability. So if you integrate it from 0 to L by 4, it will give the probability of the finding particle between 0 to L by 4. So you will simply perform the integration, and from that you will get the probability. Here the probability 0.09. So basically it is 9%. So you see the probability is also not distributed uniformly. That's why we are getting here. You see, if you see the function is somewhat like this. So this is L by 2, then this is L by 4. If you see here, the probability of find the particle will be 0 to L by 4 will be this much only. So this part only covers the 9% of the total function, so total probability. So the correct option will be option B. This will be the correct option. Then going to the next question. Question says, find out the most probable distance of the electron from the nucleus of hydrogen atom in the 1s state. Consider the wave function in ground state, that is 1s state is psi 100 is 1 by pi aq root over e to the power minus r by a. It is minus r by a, not r by a, it is minus.
एक मिनट
Minus
सर,
R.
1 minute सर, 1 minute
Sorry, yes.
सर, क्वेश्चन 7 में पाई का वैल्यू कितना डालना पड़ेगा? 3.142 ना और
Yes, you can use 3.142.
3.142?
Yes.
पाई का वैल्यू जो 1/4 माइनस 1/2 पाई, तो पाई का वैल्यू कितना डालना पड़ेगा? 3.142 है ना?
Yes, you can put 3.142.
अच्छा, हाँ वो, हाँ
So you will get,
ओके ओके सर.
so if you put the value of pi 3.142, you will get 0.250 minus 0.159. So if you see it is around 250 minus 160, so it is 0.090. Or if you see the answer, it is 0.0908. So this will be the correct option.
ओके ओके
Is
सर.
this clear to you?
ओके सर.
Okay, so then the next question says, find out the most probable distance of the electron from the nucleus of hydrogen atom in the 1s state. Consider the wave function in the ground state is psi 100 equals to 1 by pi aq pi a0 q e to the power minus r by a0, where a0 is 0.53 Armstrong, that is Bohr radius. The options are option A 0.53 Armstrong, option B 0, option C infinite, and option D 1.06 Armstrong. So I'll request you to try this question. Then after some time we will discuss. So see, this question is a bit tricky in the sense that in the previous questions we are talking about one-dimensional potentials, like potential in one-dimensional box, and the coordinate was our conventional Cartesian coordinate, x, y, z coordinate. But here, since we are talking about hydrogen atom is in space. So basically, we will be dealing with spherical polar coordinates in this question. So like the integrations we are doing dx, dy, dz. Here the integrations will be corresponding to the spherical polar coordinate systems. So you see, the wave function is given here psi 100, which is 1 by pi a0 q root over e to the power minus r by a0. Then because this is for 1s state, and for 1s we know n equal to 1, l equal to 0, and for l equal to 0, m l also 0. So this wave function represents psi l m n l m. This NLM is psi 100. And now, what is the most probable distance? So first we will find the probability, and then for most probable distance, we will take the derivative and equate it to 0, because we know if a quantity is maximum, then its derivative is 0. That is, the slope is 0 there. So if you first talk about the probability, then the probability of the finding the particle will be how much? The probability of finding the particle will be psi star d psi into d tau. This d tau will be now, so psi star is 1 by pi aq. Psi star psi, here again the wave function is real, so psi star psi product will be equals to psi star psi mod square. So it will be 1 by pi aq e to the power minus r by a0. Then this we know d tau is integration. There will be three integrations because there are three coordinates r, theta, phi. Integration of r is from 0 to r, integration of theta is from 0 to pi, and integration of phi is from 0 to 2 pi. And it will be r square sine theta dr d theta d phi. So here you see only r is present, so you will take the r part outside and we will integrate the spherical part, that is 0 to pi sine theta d theta into 0 to 2 pi d phi into r square e to the power minus 2 r by a0 into dr 0 to r. And with it we have, initially it was 1 by pi a0 cube. So this integration we know the spherical polar part gives you 4 pi. So it will be 4 by pi by pi a0 cube into e to the power minus 2 r by a0 into r square dr. So pi gets cancelled out. So the probability is r square e to the power minus 2 r by a0 into dr 4 by a0 cube. So this is the probability. Now you see, this should be maximum, because the question says what is the most probable distance? Most probable distance means the probability is maximum. So if you take the derivative of the probability, then it should give 0. So taking the derivative, that is d by dr of p is equal to 0, we'll get d by dr of, this is 4 by a0 cube r square e to the power minus 2 r by a0 equals to 0. Then 4 by a0 cube is taken out, r square e to the power minus 2 r by a0 into minus 2 by a0 plus e to the power minus 2 r by a0 into 2r, which is equal to 0. then 4 by A0 Q. This is there are two equations. One is 2 by A0. If you take common 2R e to the power minus. So if you take this part common, 2R e to the power minus 2R by A0, it will be 1 minus R by A0 equal to 0. So here there are three terms, R e to the power minus 2R by A0 and 1 minus R by A0. So all can be 0. So R can be 0. Then e to the power minus 2R by A0 can be 0. And 1 minus R by A0 can be 0. So these are the possibilities. R equal to 0 is not possible because you see R equal to 0 means it is the nucleus, and we know electron can't stay inside the nucleus. So R equal to 0 is not a possible answer. Then e to the power minus 2R e to the power minus 2R by A0 equal to 0 gives us R equal to infinite. Again, R equal to infinite is not possible because according to the feasibility of wave function, the wave function should be 0 at R equal to infinite. So the electron can't be present at R equal to infinite. So these two available answers are not feasible or not acceptable. So if you solve it, you will get 1 equals to R by A0 or R equals to A0. So the most probable distance is A0. So the correct option, we know A0 is nothing but 0.53 angstrom. So the correct option will be option A. So is this clear to you? Yes. Basically,
Sir.
here the question was,
Yes,
here
sir.
the question was, okay, so let me explain it once again. Here the question was, what will be the most probable distance of electron from the nucleus in the hydrogen atom in 1s state? So in order to determine the most probable distance, we need the wave function, and the wave function of the 1s state was given. It was 1 by pi A0 Q e to the power minus R by A0. And the options were A, B. A was 0.53 angstrom, 0, infinite, and 1.06 angstrom. So if you take the integration, this is psi star psi d tau. This is 1 by pi A0 Q e to the power minus 2R by A0. And the integration is 0 to R, 0 to pi, and 0 to 2 pi. This is for R, this is for theta, and this is for phi. But here you see this, the wave function has only R dependence. So we will take the integration over R and we will take the integrations over theta and phi outside. So separating these variables, the integration of these two quantity, that is theta and phi, will give us 4 pi. Then R square e to the power minus 2R by A0 will give us the actual value. So if you calculate it, the form of the probability was 4 by A0 Q R square e to the power minus 2R by A0 dr. So for this probability to be maximum, the derivative should be 0. So if you when you equate the derivative to 0, then d by dr of PR is 0. So we can write it as PR as it depends upon R. So this is d by dr of 4 by A0 Q R square e to the power minus 2R by A0, which will be 0. Then if you solve it, there are three possibilities: R equal to 0, R equal to infinite, and R equal to A0. All these three are present in the option, but which will be the correct option? R equal to 0 is not an acceptable option because R equal to 0 means nucleus. We know nucleus is the nucleus is at the center of the atom. So since electron can't be inside the nucleus, so R equal to 0 is not a correct option. Similarly, R equal to infinite is also not a correct option because at R equal to infinite, the wave function becomes 0. So since the wave function is 0, since the particle is characterized by the wave function, so where the wave function is 0, the particle can be present there. So the option R equal to infinite is also not acceptable. Then the remaining option is R equal to A0. So the correct option will be R equal to A0. That is at bore radius value, the particle has the maximum probability. So it is the most probable distance. Yes, is it clear to everyone? Okay, so let's go to the next question. The next question says, find the expectation value of R for hydrogen atom in the ground state. The ground state hydrogen atom represented by the wave function psi 100 equal to 1 by pi a02 exponential minus R by a0. So this question is pretty much similar to the questions we had solved in the initial part of the session. In there it was given what is the expectation value or average value of x. So here the expectation value of R is given and the wave function is given. So simply we will do the integration from 0 to R, 0 to pi, 0 to 2 pi, psi star, psi, R, dr, d theta, d phi, r square, sin theta. This will be the expectation value of R. So R is here and the remaining part are here. So if you calculate it, what will give? So the expectation value of R will be 1 by pi a q, pi a02 will be taken out because it is a constant. That will be 0 to R means 0 to infinite. Here it is 0 to infinite. Zero to infinite. Here r square r, which is rq e to the power minus 2 r by a0 dr 0 to pi d theta 0 to 2 pi d phi. So if you calculate, we know this part is 4 pi. So it is 4 pi by pi a0 q 0 to infinity rq e to the power minus 2 r by a0 dr. So again, if you make it the change of variable, if you suppose 2 r by a0 is z, then dr will be dz into a0 by 2, and the limit of the integration will be changed. No, limit of integration will be same because at r equal to 0, z equal to 0, at r equal to infinity, z equal to infinity. So it will be 4 by a0 q into a0 to the power 4 divided by 2 to the power 4, because here a0 into integration of 0 to infinite z to the power 4 e to the 4 minus z to the power 3 e to the power minus z dz. Now this integration has a formula which is called as gamma of 4. It's a gamma function. So it will be 4a0 by 16. This is 2 to the power 4 is 16 into gamma 4, and gamma 4 is given by 3 factorial. That is gamma n is n minus 1 factorial. So gamma 4 is 3 factorial. So it is 4 by 16 a0 into 3 factorial, which is 3 into 2 into 1. So 3 2 is 6. So 3, so it is 2, it is 8, then it is 2. So it is 3 by 2 a0. So the expectation value of R in hydrogen atom is 3 by 2 a0 in the ground state, psi 100, which is 1 by pi a0 q root over e to the power minus r by a0. That's not 2r. E to the power minus r by a0. This is the state. This is the expectation value 3/2 A0. So the correct option will be option B, 3/2 A0. So is this clear to you? So basically in this question, it was asked that what is the expectation value of R in the state 1s. So if you calculate the expectation value, we have to perform the integration. So if you perform the integration and put those values, the expectation value of R will be 3/2 A0. Then let's proceed towards the last question of the day. Question says the 2p state of the hydrogen atom is represented by the wave function psi 210 equals to 1/32 pi a0 to the power 5 r e to the power minus r/2 a0 cos theta. What is the expectation value of r in this state? Given a0 is 0.53 Armstrong. The options are option A 1.05 Armstrong, options B 1.53 Armstrong, option C 2.12 Armstrong, and option D 2.65 Armstrong. So I'll give you a few minutes to try this question. After some time, we will solve and find out what will be the correct, what will be the expectation value of the R. Yes. So how we will solve it? Similarly, the expectation value of R will be psi star 210 R psi 210 3 tau. It is psi square R 3 tau integration. So integrating, it will be 1/32 pi a0 to the power 5 r square e to the power minus r/a0 cos square theta r into r square sin theta d theta d phi dr. So to solve it, 1/32 pi a0 to the power 5 0 to infinite r to the power 5 e to the power minus r/a0 dr 0 to pi cos square theta sin theta d theta and 0 to 2 pi d phi. So to integrate, it will be 32 a0 to the power 5 into a0 to the power 6 into 5 factorial. So this will give you a to the power 6 into 5 factorial, and this part will give you 4 pi by 3. So it will 4 into 5 into 4 into 3 into 2 divided by a0 divided by 32 into 3, which will give you 5 a0. So 5 into 0.53, it will give you 2.65 Armstrong. So the correct option will be option D, 2.65 Armstrong. So this will be the correct option. So the probability of, so the expectation value of R in the state psi 210 is 5R, which is 5 into 0.53 Armstrong, which is 2.65 Armstrong. I hope this is clear to you, or if you have any doubt, you can ask me, or any doubt related to the lectures or related to the course, you can also ask me. So with this, we have come to the end of the today's session. So I thank you everyone who have joined today. I hope you will be performing good in the course and also will be performing good in the exam. So that's it for today. Have a great day.
Thank you, sir.